STC on a breadboard. So we've got the 40 pin STC89C52 chip here on the breadboard. It's got 5 volts going into pins 40 and 31, which is some sort of enable pin. I'm not sure if that's necessary, but anyway, got that in. We've got a resistor and an LED here on pin 39, which is P0.0, and write a program to make that flash on and off. Crystal connected between pins 18 and 19, and little capacitors from each side of the crystal down to ground. Ground into pin 20. We've got the reset, which is this capacitor, and there's a resistor under there into pin 9. So this is a 4.7 microfarad capacitor going up to +5. Pull down resistor is at 10k down to ground. These two wires go to receive and transmit, which are pins 10 and 11, and that's it. Now this is the device I'm using to program the chip. This is a FTDI board, a 5-volt one, which I've got the 5 little dots on the top and 5 on the bottom, because I've also got a 3.3 somewhere. This is the board you buy if you want to program Arduino minis. It plugs straight onto a mini. So it's basically just a USB to 5-volt TTL converter. You can buy these on eBay for £3 or £4, something like that. So we'll plug that in, and it's COM6 on this computer, I think. Now you could just take wires from there and plug them straight into the breadboard. All you need is 0 volts, 5 volts, transmit and receive. But you have to plug the 5 volts in at just the right moment, so I've got this little switch here to do that for me. This is just a switch in the 5-volt wire. And I actually made this board to adapt these pins into the correct order for that Bang POV clock thing. But there we go. So if I do that, it's switched on, and you saw the light just flash briefly there as it comes on. But the LED isn't doing anything at the moment, even though it's powered up. So now we'll run this program. This is the programmer program. Read chip info. It's trying to read it. Power up, and you see it's ready. If you can see that. It's an STC89C52RC LE52R, this particular one. It's detected it's got an 11.1 meg crystal approximately, and it knows the bootloader version. Not that any of that really matters, it's just showing that it can talk to it. So we'll power it down again, and we'll put a little program into it to make the light flash on and off. So this is about the simplest program you can have. This is a sort of blink program for this chip. So we include reg52.h, we've got void main, integers I and j, so we can use those just to count up for a delay, and then while 1, so it's going to do this over and over and over forever. Port 0, exclusive OR with 1, so that's going to toggle this bit that's attached to the LED on or off, and then we count up to 100,000 here as a delay, and then do it over again. So I've made that into a hex file. So if we go, so we're going to try and program this program now into the chip. So click on that, switch on, program's gone in, and you can see the LEDs blinking on and off now. And if we were to, you see the sort of rate we're going there, what's about 1 flash a second, maybe a bit more. If I alter this to not be in high speed mode and send the same program through again, now you can see it's, oh no, it doesn't do it until we power off and back on. And you see now it's going half as fast as it was before. So that's this high speed, low speed mode. So put it back into high speed again. Switch on. So it's in there, it doesn't actually adopt the high speed until we cycle the power again. And there we are, it's going twice as fast. That's it. Thanks for watching.